Today we will look at the response of parallel RC circuit to unipolar current input. Consider an RC circuit, resistor is 1 kilo ohms, capacitor is 1 microfarad, and this is the input that we are feeding to the RC circuit. Between the time interval 0 to 5 milliseconds, the current of 5 milliamperes will flow through the circuit. Time period is 5 milliseconds and amplitude of the current is 5 milliamps. And from 5 milliamps to and from 5 milliseconds to 10 milliseconds, the current is 0 and is replaced by an open circuit. Now, since R and C are in parallel, the voltage seen across R and C will be same. We want to find the current flowing through the capacitor and resistor, and voltage across capacitor will be same as voltage across resistor. Current flowing through the capacitor can be calculated using the AC is equal to I in minus IR. Let's look at how the voltage across the capacitor can be calculated. So from 0 to 5 milliseconds, the input current of 5 milliamps is available and the capacitor starts charging. Now the charging equation of the capacitor can be given as V in of t into 1 minus e to the power minus t by RC. Now between 5 milliseconds to 10 milliseconds, the input current drops down to 0 and the current source is replaced by an open circuit, and hence the capacitor starts discharging through the resistor. Now here it has a path to discharge, unlike how it was in series R and C. In series R and C circuit, there was no path for the capacitor to discharge when current source was open. And the voltage across the capacitor can be calculated here using this equation. 10 milliseconds to 15 milliseconds, again 5 milliamps is available and the capacitor starts charging again and the initial voltage will add up along with it. Here we have seen the current flowing through the capacitor and the voltage across the capacitor at 5 milliseconds, 10 milliseconds, 15 milliseconds and 20 milliseconds. Let's consider points within 0 to 5 milliseconds with the time interval of 200 microseconds and see how it looks like. This is the input the current that we are feeding to the RC circuit. Resistor is 1 kilo ohms, capacitor is 1 microfarad. Now the voltage across the capacitor is calculated using the equation V in into 1 minus e to the power minus t by RC. Here we have considered a time interval of 200 microseconds between 0 to 5 milliseconds. After 5 milliseconds, the input current drops to 0 and this is how the voltage across the capacitor looks like. It is the discharging equation Vc of 5 milliseconds into e to the power minus t real minus t start by RC. T real is here is the real time. T start is 5 milliseconds. Similarly, between 10 milliseconds to 15 milliseconds, T start will be 10 milliseconds. On plotting these values, we can see how the current flowing through the capacitor looks like. The capacitor current changes rapidly because current is directly proportional to the instantaneous slope of voltage. And also here, V in is calculated as I in into R. Here as well, we have considered V in is equal to I in into R. Here we can see that current is changing from 0 to 5 milliamperes, and hence that is why we see the spike here, current spikes here. And similarly, when it drops down to 5 milliamperes to 0, again we see a spike of minus 5 milliamps. And the capacitor slowly charges and discharges. VR can be calculated as IR by R. IR is equal to VC by R. Let's simulate this and check. Now on simulating this is the input current that we are feeding. This is the voltage across the capacitor and resistor. This is the current flowing through the circuit and this is the current flowing through the resistor, which looks similar to voltage across capacitor because IR is equal to VC or VR by R. This is how the current flowing through the capacitor, voltage across the capacitor and current flowing through the resistor looks like. Here is the summary. We can see how the unipolar input current has transformed the current flowing through the capacitor, voltage seen across the capacitor and the voltage seen across the resistor. If the time constant of RC circuit is comparable to input's time period, then it will not resemble the behavior for unipolar current input. Thank you for watching this video.